Hey guys, so these are going to be concentration problems, solubility, dilutions, and then colligative properties. I'll post a second video of solution stoichiometry problems as well after this, but I wanted to get most of these out of the way and do solution ones second. So let's start here with concentration. Parts per million equation. Notice for each of these, it'll specify exactly what you want to calculate it in. Whether it's concentration by volume, by mass, parts per million, or molarity. So we'll just get working. So I have 7.5 milligrams of helium gas dissolved in 1,200 grams of water as far as concentration in parts per million. So parts per million is mass of solute over mass of solvent. And I have 7.5 milligrams to convert to grams and move the decimal 1, 2, 3 spots. Get 0.0075 grams over mass of solution, which is 1,200 grams plus 0.0075. That doesn't contribute much, so I can essentially ignore it. Multiply times 10 to the 6th. And I would get 0.0075 divided by 1,200 times 10 to the 6th. 1 there is just 1 times 10 to the 6th, or 10 to the 6th. Oops. There we go, 6.25 parts per million. Should have been multiply, not divide. That's why I had to fix that there. Similar type of problem here, 40 milligrams to 3,100 grams of water. What's the concentration in parts per million? So here I'll convert to milligrams as opposed to grams. So I have 3,100 grams. I need to move the decimal 1, 2, 3 spots to the right. So get that many milligrams of water times 10 to the 6th. I plug that in the same fashion. 40 divided by 3, 1, 0, 0, 1, 2, 3. Multiply that times 1 e to the 6th, and I get 12.9 parts per million. That's parts per million. Number 3, what is the percent by mass, which again is WW or MM, of silver nitrate if 20 grams of solute dissolved in 135 grams of solution. So notice it's solution, so I don't have to add anything in my denominator. I can just take solute mass divided by solution mass, multiply times 100%. I get 20 divided by 135 times 100 to give me 14.8% by weight or mass there. So calculate the percent concentration by volume for methanol if 95 milliliters of methanol is dissolved in 705 milliliters of solvent. Here it is solvent expressed separately, so I do have to add. I have 95 milliliters over 95 plus 705. That's milliliters there. 95 plus 705 is 800. So that's equal to 95 milliliters over 800 milliliters times 100%. 95 divided by 800 times 100 is 11.9% by volume. So 5 and 6 here, we have show the math needed to prepare solutions. So these are similar to the ones we did today. Remember that the mass given here, that's going to be the entire mass. So 100% of the mass is equal to 250 grams. And I'm trying to find what 35% would be. How many grams? A couple different ways: turn it into proportion, cross multiply and divide, or multiply 250 times 0.35, which is 35% is a decimal. This is the other way you could do it. Either way, you get 87.5 grams, and that's solute. So to find solvent, I take 250 and subtract 87.5 grams. I do that, and I get 162.5 grams of solvent. Water, acetic acid for each of those. Similar type of problem in number 6 here. That was the bell. Show the math needed to prepare 175 milliliters of 15% by volume potassium nitrate solution. So similar type of deal. 100% is equal to 175 milliliters. 15% is what I'm trying to find, and it's some volume in milliliters. Turn it in proportion, cross multiply and divide, or take the total volume, multiply it times 15% as a decimal to give me 26.25 milliliters of KNO3 or solute. So again, to find solvent, I subtract that number from 175, or my total volume. So 175 minus 26.25 is equal to 148.75 milliliters of solvent. So there'll be lines provided on the test tomorrow for you to place those two answers in the respective spots. Solute first, and then solvent. So that's concentration. What we have left is molarity, and then we'll go into dilutions and stuff. So how many grams of silver chloride are in 150 milliliters of 0.25 molar silver chloride solution? That should be a question. So I have my molarity triangle. I want grams, which I need to get to moles first to figure out grams. So I take molarity times liters. I have 0.25 molar times liters, 0.150. Did a quick conversion there. It's equal to 0.25 times 0.15, which gives me 0.375 moles. But then I have to convert to grams of silver chloride, and every mole using its molar mass. Silver has a mass of, where is it here, 107.87. Add that to 1 chlorine, which is 35.45, and I get 143.3 grams per mole. I multiply that out, and that should be 0.0375. I'll just rewrite it. 0.0375 moles. 0.0375 times 143.3 is equal to 5.4 grams of silver chloride. Number 8 is asking me to calculate molarity. So to calculate molarity, I take moles divided by liters. I'm given moles in milliliters, so I don't have to do molar mass conversion here. But I do have to do a liters conversion, so move the decimal 3 spots to get 4.475. That's moles per liter, which is molarity. I divide that, and I get 1.6 molar solution of sodium chloride. So now I have dilutions. And it's asking me what volume of a 5 molar solution of sulfuric acid would I need to use to make 250 milliliters of 1.25 molar solution. So of, which isn't expressly written here, but it's given there. So 1.25 moles of 250 milliliters. Remember, volume units don't matter as long as it's the same on both sides. And I have 5 molar. It's finding my second volume. What volume? Divide by 5 molar on each side. And that would give your answer 1.25 times 250 divided by 5 is equal to, your volume is equal to 62.5 milliliters. And I guess I didn't say it, but it's M1V1 equals M2V2 equation. Number 10, what were the final concentrations, so I'm looking for molarity, of 200 milliliters of 4 molar, so those two things I have together, diluted to 1.2 liters. So I have 4 molar, 200 milliliters, and I'm finding concentration, so molarity, and I have volume 12, or 1.2 liters, 1200 milliliters. Divide each side by 1200. It should be 4 times 200 divided by 1200 is equal to, your molarity is equal to 0.67 molar solution. And that'd be your answer. So for numbers 11, 12, and 13, I'm going to use the solubility curve I have here, so I'll be flipping back and forth between the two. So this first one, number 11, is asking me, is the solution saturated, supersaturated, or unsaturated if 110 grams of ammonium chloride is dissolved in 100 grams of water at 60 degrees Celsius? What type of solution is that? So I find the temperature, 60 degrees Celsius, find 110, which is right here. It's asking me about ammonium chloride, which is far above that line, so it would be supersaturated. And that'd be all you do. On the line is saturated, underline is unsaturated. Number 12, how many grams of hydrochloric acid can be dissolved in 25 grams of water at 40 degrees Celsius? So find HCl at 40 degrees. It's right here, roughly 62 grams. So at 40 degrees Celsius, again, 62 grams of hydrochloric acid for 100 grams of water. And here it's saying I need to find how much per 25 grams of water. So I can divide by 4 or cross multiply and divide, because 100 divided by 4 gives me 25. Either way would work. 62 times 25 divided by 100 gives me 15.5 grams of HCl. Give me my answer there. So setting up the proportion from the chart and then getting to what you don't have directly placed on the chart. Number 13 is a similar type of problem, except instead of getting smaller in mass of water, I'm getting bigger. So how many grams of potassium chloride can be dissolved in 450 grams of water at 60 degrees Celsius? So 60 degrees Celsius, find potassium chloride, this line right here. It's roughly 45 grams. So I have 45 grams of KCl per 100 grams of water. And that's asking me, I want 450 grams of water now. So it's multiply times 4.5, or cross multiply and divide. Either way works. And I will find that I need, or can dissolve, 202.5 grams of KCl. It needs to be a little bit higher there. So it's 202 grams of KCl. So that's solubility curve questions. So then lastly, in this video we will go over, that's the solubility curve I was using. These are colligative property problems. You remember you have your change in temperature, whether it's boiling point or freezing point, is equal to I, and then the Molar constants, which I gave you here, this one should be Kf, times m, which is moles of solute per kilogram of solvent. So number 14, it says calculate the change in boiling point temperature if 1.8 moles of sodium chloride is dissolved in 1600 grams of water. So saying delta TB is equal to I Kb m, which is moles of solute per kilogram of solvent. I'll start filling stuff in. I have 1.8 moles of solute, 1600 grams or 1.6 kilograms of solvent. Kb is 0.512 degrees C per mole. And I have 2 atoms in sodium chloride, 1 sodium, 1 chlorine, to give me an I of 2. And if I calculate that out, 1.8 divided by 1.6 times 0.512 times 2 is equal to a change in temperature of 1.2 degrees Celsius, rounded there. And it's boiling point, so if I remember what we looked at today, boiling point, freezing point. Boiling point gets more positive, freezing point gets more negative. So my value is going to be a positive 0.12 to 1.2. Don't necessarily need that positive there, but I wanted it for emphasis. Number 15 is asking me about freezing point, which is essentially the same equation. And I'll actually write m out here, moles of solute per kilogram of solvent. So notice I'm given a gram of solute here, a molar mass. So 75 grams of calcium chloride. To get to moles, I have to do a molar mass conversion. Every mole of calcium chloride has a mass of 111 grams, but I'll double check that. 40 plus 70.9 is roughly 111 grams. So 75 divided by 111 gives me 0.68 moles of calcium chloride. I have 1900 grams or 1.9 kilograms. The rest of the stuff I can kind of get as I go along here now, so once I make that conversion, I just got to kind of plug stuff in. So I, the number of atoms in calcium chloride, 1 calcium, 2 chlorine, so I have an I of 3. Kf is given to me, 1.86 degrees C per mole. Moles of solute, which I calculated there, 0.68 mole. And I have 1.9 kilograms of solvent, 1900 divided by 1000. So if I type that in, 3 times, actually I'll start on the other side, 0.68 divided by 1.9 times 1.86 times 3 gives me a change in temperature. Oh, I made a mistake in calculating. It's 0.68 divided by 1.9 times 1.86 times 3. 1.99 or 2 degrees Celsius. Change in temperature of 2 degrees Celsius. And it's freezing point, but I depress it, it goes down, if you remember from above here. My freezing point changes in temperature are negative when I add solute to it. So those are some of the problems. I'll post a separate video for solution stoichiometry after this one. Enjoy!